All right, again, this is very similar to the last two, except now we are doing standard deviation and variance. So the same thing, same, almost the exact same places in StatDisk, and let's get going. All right, we will be looking for a point estimator. There's a little bit of difference here, but not a lot. The point estimate, okay, the S squared is the point estimator of the population variance. We will be doing a confidence interval, the estimate of the population standard deviation. We will be using chi-squared. Now, this one's a little different because it is not the middle. So we have to do a few things differently if we're doing it by hand. Okay, a chi-squared distribution, it's normal distribution population with a variance of sigma squared. It is an independent sample of size n. Each sample computes the sample variance. The sample statistic has a sampling distribution called chi-square. All right, the formula for chi-square is n minus 1, s squared, your sample, divided by your population. Now we denote a right-tailed critical value by chi r squared. R is usually a subscript, so it looks a little funny here. And this one here is the left tail, or the xl squared. All right, so these are your chi-squares. It's the right and the left tail because they are not the center, because remember your distribution now is not normal, right? It's always skewed, so it's not in the middle. Okay, degrees of freedom is the same, it's n minus 1. Remember they're skewed, and they're likely to be skewed to the right. They are not normal. So since they are not normal, we cannot have them in the middle and add or subtract our error. We have to do both sides individually. Okay, chi-squared can be 0 or positive. It cannot be negative. Okay, chi-cube distribution is different for each number of degrees of freedom. As the number of degrees of freedom increases, it becomes closer to our normal distribution, just like our other ones. Okay, the chi-squared distribution is not symmetric, so it does not fit. We cannot do this. All right, this is not legal because it's not symmetric, it's not in the middle. We have to calculate each one individually because it is a skewed distribution. All right, we have a simple random sample of 22. All right, so we got 22, so our degrees of freedom is 21. We are going to construct a confidence interval. We'll be using the StatDisk to do this. We have to do the left and the right critical values. We cannot do them together. Chi-squared of a 95% confidence interval. And we have to do chi-squared of the left and chi-squared of the right. They will be different since they are not symmetrical. Whoops. All right, so we're going to go to StatDisk, Analysis, and we're going to chi-square distribution with degrees of freedom of 21. Since it's 95, we're going to use a 0.025 area to the right, and then we'll use 1 minus the 0.025 to find the area to the left. So back to StatDisk, Analysis. We're going to do a confidence interval. Oops, I forgot. Probability distribution, a chi-square distribution, degrees of freedom. This time we have 21. All right, we do not know our chi-square area, but we do know the area to the left. Remember, it was 95, so we're going to use 0.025 and evaluate. And you need to write down this number, 35.478842. That is our number to the right, our chi-squared right. Now we have to do the number to the left. So it's 1 minus 0.025, which is 0.975. Hit evaluate, and then we get the 10.2, whoops. Sorry about that, I was in a different screen. The 10.282908. All right, back to our notes. So degrees of freedom, area to the right, we did 0.025. So chi-squared right was 35.479. Area to the right now For the left, we have to do 1 minus the 0.025 when we plug that in to find our left. So this is area to the right. This is what you're typing into in our stat disk. So even though it says area to the right, we are finding the left because we were taking 1 minus the 0.025. So when we take the 1 minus the 0.025, we get the 0.975, which gives us the 10.283. So here's our left area, here is our right. Okay, I hope you've done well. Now, I want you to pause and do yours. All right, I hope you did well on stat disk. Your degrees of freedom should have been 14. When you were finding chi-squared right, you should have put in the 0.025 to get to 26.1189. When you were doing left, the right you should have typed in was 1 minus the 0.025, which is a 0.975, giving you 5.6287. All right, now that we know how to find our chi-squared or our critical values, now we got to find everything else, our intervals, right? All right, same thing stays here. None of our notation is changed. Okay, but now we got to construct that interval. This time requirements are ridiculously important. Again, it has to be a simple random sample, which we must almost always have. It has to have a normally distributed values. Okay, this is very, very strict. If it is not normally distributed, we cannot do this. It will not work. All right, if you have to do this by hand, it's n minus 1 times the standard deviation squared of the sample over your right, n minus 1 standard deviation of the sample squared over your left. All right, so we'd have n minus 1 s squared. We take the square root, just to find this is your variance and this is your standard deviation. Standard deviation is usually where we want to end up. Okay, we're going to round the confidence intervals to one more decimal place, and the summary stats stay the same, just like before, nothing different. Same number of decimals. We'll just use what stat disk gives us. All right, now we have to check first to make sure that this is working. So we're going to use dataset, IQ, set 7, IQ, and lead, index B. So you're going to go to dataset 7. There's going to be 22 full IQ scores for the group with a medium exposure to lead, group 2, have a standard deviation of 14.29263. Now, consider this sample to be a simple random sample and construct a 95% confidence interval. All right, first, we have to check the requirements. The sample can be treated as a simple random sample. The histogram has a shape that is normal to the distribution. So when you're in stat disk, you're going to go to your data sets, your 13, and we are on number 7, IQ and lead. All right, and now we're going to do data, and we're going to check for normality. And we are looking at where is my IQ? All right, the full IQ is at the bottom. We're going to look at our histogram. And it is a very rough bell shape, but it is a bell shape, so this is good. So we can use this. Now, use StatDisk to find the critical values. So now we're going to go to Analysis, Probability Distribution, your chi-squared, and degrees of freedom. We're going to have 21 this time. And area to the left, or right, 0.025, evaluate, and you should have gotten 35.479. Now the other area is 0.975, evaluate, and we get the 10.28. All right, I hope you've done well with that. Let's go back to our notes. So we've checked our normal history, make sure we have a bell-shaped curve, which it's rough, but it's good enough. We've used StatDisk to find our critical values. Now we can construct our interval for variance. by hand. It's n minus 1 s squared over the right chi-squared r, and the left is a chi-squared l. Now, if we do stat disk, okay, I'm sorry about that. My husband walked in. Anyway, so let's go to stat disk. So you're going to go to analysis. You're going to go to confidence intervals. You're going to click on the standard deviation one sample. So we have a confidence interval of 95. 21 is our sample because we had 20. Oh, sorry. That's 22 because they do that for us. And our standard deviation, which was given in the problem, of 14.29263. Hit evaluate, and we've got 120.9, the variance of 417. The standard deviation is on the first one is 10.99, standard deviation of 20.42508. Gotta love technology, right? All right, so we've got our confidence intervals for the variance and the standard deviation. What this means is that we have a 95% confidence that the limit of 11 and 20.4 contain the true value of the standard deviation of our population, which makes us happy. It cannot be written as S plus or minus E, all right, because it is not in the center. So remember, this is not a thing. This is bad. You cannot do this for standard deviation. It is a skewed distribution. All right, pause and try yours. All right, when you typed it in, you should have gotten your chi-squared to the right is 26.11. Your chi-squared to the left is 5.62. Your standard deviation interval was 115.826 to 537. Your variance, your standard deviation was 10.76 to 23.8, which means we are 95% confident that our population standard deviation falls within the range of 10.76 and 23.18. Hope you wrote that all down. Okay, sample size. Again, we will be using stat disk and plugging in everything that we need. We have a 99% confidence. We have a standard deviation for IQ scores. We want to be within 5% of the true value. So now we go to the same place again. Stat disk, sample size, except it's standard deviation. We have a 99% confidence level. Margin of error is 5. You hit evaluate, and we have to have 1,336 people to estimate the standard deviation. That sounds like a lot to me. I don't know if we're going to be able to do that. Variance is 5,458. All right, pause and try yours. Okay, when you plugged it in, you should have gotten 768 people, the number that you needed for your sample space. All right, good luck with your homework. I hope you do well. If you have any questions, please post them online or ask me in class when you get here. Have a great day.